Howdy folks, welcome to week 3 for research methods. This week we're going to be taking a look at how to select a problem and review research. What does that mean? Well, let's take a look at the series of subsections here to give you an idea. First, we're going to look at scope. Scope is how many or how much of a research question you want to investigate. So whether or not you are investigating too many things or too few things in order to make a compelling article is something you're going to want to be careful about. You never want to get yourself stuck investigating 50 different things and then forget what your original intent was. Next up, in the second section, we'll be looking at finding and reviewing literature. So that's where I'll actually show you how to get academic papers from the internet so that you can read them. Next, in the reading out of order section, I'll give you some more tips on the sections of academic papers and some suggestions on how to best read them or skim them for information. Finally, in the evaluating research section, we'll take a look at limitations, which are pretty much complaints that people may have about research, and how academic writers actually kind of preempt those questions or complaints and try to give you answers to them, so that their research is well defended before people have a chance to pick out problems with it. So let's go ahead and get started by identifying scope. So in order to explain scope, we're going to be talking about the first research paper that I ever wrote. This was about kind of a simple question. I asked students, okay, what grade do you think you're going to get on your next test in your college class? And so my idea was that very, very few students hope to get a failing grade. Most students hope to get a good grade. And so because of that, their grade predictions would be affected by their desires to do well. And to give you a little bit more context, this is a graph that I was familiar with when I made that when I made that claim, because a lot of grade predictions that students make in colleges look like this. First, let's take a look at the graph. Here we have grades on the left side, and on the bottom we've got performance quartiles. So these are the lowest performing students, and this is the top 25% of students. So in this class, on this particular test, the bottom 25% of students got about a 72 on the test. The top 25% of students got an average of about 90 on the test. And let's take a look at grade predictions. Oh, there's the trend line for that. So let's take a look at the grade predictions. You'll notice that the lowest performing students have this big overconfidence in their grade predictions. They thought they were going to get a B, and they actually got a C. Then the higher levels have smaller and smaller grade prediction overconfidences until you get to the actually highest performing students who are a little bit underconfident in their grade predictions. And so by looking at this graph, I thought that maybe what was happening is this motivational issue, that students want to get a good grade, so most students kind of predict about an 80. And that reflects here because grade predictions are all around the 80 to 85 mark, while test grades are a much more dramatically changing number. So in order to investigate this, one of the things that I did was take a look at explanations that people have already given for this. I'm going to skip through this because really you don't need to know those explanations. Instead, let's think of, well, what questions should I identify in before I attempt my research? And when I started to think of potential research questions, I started to come up against a problem. I had a lot of them. There were a lot of things that we could investigate and a lot of things that we might want to be careful about. If I put them out into a list, it almost felt like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It almost felt like I had a million different research questions that I could investigate, and it felt as though there was no way we could investigate all of them in one bit of research. And realistically, this is kind of crazy to try and answer all of these questions in one bit of research. So this is where the idea of scope comes in. Scope is to what extent you want to investigate your overall research question. All of those research questions here on this past slide come from one main one. Do students' motivations make them overconfident? Are students making overconfident grade predictions because they want to do well in class? But all of these other little nitty-gritty things could bog down my research question, and I wouldn't really be able to answer the whole thing. So you have to be careful. If you have too much scope, if you're trying to investigate too much at one time, you're going to get confused. You're going to lose yourself. Your paper is going to be a million pages long, and no one will really know what it's even actually about. But if you're not identifying enough stuff to investigate, then you probably haven't adequately worked through your research question. It's important to get all of your bases covered, or at least cover a fair few of them, in order to say that you've answered a research question. So a couple of ways that we can work with our scope or choose exactly how much scope we want is to think about the claims and assumptions that we've made in our paper. A claim is just anything where you say something is true. For example, if I say that many students make overconfident grade predictions, that is a claim. And whenever you have a claim, you're going to want to back that information up or prove it in your research paper. So that could add to the scope of your paper. Now, something that you need to be careful about is the assumptions in your research question. Assumptions are whenever you have part of your research question that insinuates or includes information that we haven't necessarily proven. So, for example, if I say students often make overconfident grade predictions, you have a couple assumptions there, like the readers are going to assume, what does overconfidence mean? Readers are going to assume, or you may assume, the specific scales involved, or that you're only dealing with college students. And so both of these are going to affect the scope that you have. And one way that you can shore down the number or the amount of scope in your paper is through the use of precedent. Precedent is simply something that identifies something that people have done before. So if you are going to investigate people's happiness as it relates to the time of day, instead of creating a whole new questionnaire about happiness and having you assume that it works, you might use an existing survey, and thereby you would be using precedent to say, hey, we know this survey has to do with happiness based off of based off somebody's previous research or my previous research. Another place where precedent pops up a lot is actually in law and the judicial system. So a lot of our laws and a lot of lawyer stuff that people do is based off precedent. So in a court case, when a judge decides something, uh, future court cases are going to look at that previous decision to see if it can provide some guidance on how things should be decided. And so it makes sense that if somebody has already done a research study showing that this survey on happiness is actually related to happiness, then we can use that survey and we can cross out an assumption or a claim in our paper and move on to the research question that we're actually trying to target. So in a way, precedent helps you get around the issue of having to demonstrate claims and assumptions by saying, well, somebody already did this, so let's move on. We don't have to reinvent the wheel every time we do research. Okay, so there are many different assumptions people can make that can make their research kind of crummy. that can make science kind of crummy. And we have to be very, very careful about those things. This is a list of cognitive biases, of things that make people make mistakes in science or in everyday thinking. I'm going to go through them very, very quickly. So first off, good stories. Whenever people give you a personal story or an example that seems to make a lot of sense, folks will often take that example to be hard truth. However, science does not believe in one example. Instead, as scientists, we gather data from a lot of different examples. You want to have at least, you know, a couple dozen bits of information to demonstrate that this thing happens every single time, instead of one story and assume that that story is true every single time. For example, a lot of people will say, if you ask, like, is it okay to hit your kids? Is that a good way to teach them how to be good? Well, a lot of people will say, well, my parents hit me and I turned out all right, so therefore that must be a good way to discipline your children. Research actually shows that that's not actually true. And that in many cases, or most cases, disciplining your children through any sort of violent means is actually worse than not doing it. But sometimes it will work, and so we want to avoid assuming that one example is true. We always want to gather more information. The availability heuristic is that things that easily come to mind are more likely to be thought of as true. So an easy example for that is what kills more people every year? Dinosaurs, sharks, or cows? So obviously it's not going to be dinosaurs, but most people will say that sharks kill a lot of people each year. The actually true answer is cows kill more people each year, and that is because there are more cows and more people around cows than there are people around dinosaurs or sharks. That being said, sharks come to mind as a very available, dangerous thing, so people may often say, well, sharks are more dangerous, sharks kill more people. The present bias. This means that you're paying attention to hits and not misses. What do I mean? Well, in this case, it's very much like the good stories example. It's the idea that if you have one situation where something worked out and 3 or 4 situations where it didn't work out, but they're not easily pointed to, then you're going to ignore that. So what does that mean? Say, for example, you feel like when you're driving around, you sometimes have streetlights come on right as you go under the streetlight. That feels like you're psychic, but actually that's not realistically true because you're ignoring all of the different times that streetlights didn't come on when you went under them, and that's because it's easy to forget those. It wasn't really very special. Um, Confirmation. Another example for this is the psychic coin example. This one's also easy to explain. Uh, so flip a coin and guess what the answer was. If you got it right, great. But if you didn't get it right, a lot of people will report kind of feeling that they knew that they were guessing wrong, or a lot of people will report that they were really sure that they were going to get it right. And the thing is, it's very easy to remember the times where you guessed the coin right, and very easy to forget the times when you didn't guess the coin right at all. Confirmation bias, this is something that you guys probably have heard of before. It's really easy for people to do this. Look for information that just proves them right. There are a lot of examples going on in current times, especially because of the internet, but so I'll just skip those examples. I'll try and stay away from being political or talking about anything you might not be happy with. But let me see if I can come up with an example for confirmation bias. If you think that the movie Matrix came out in the year 2000, you might go to Google and type in Matrix 2000, and because you would assume that you're right. So because you're looking for information that proves you right, you would start out by looking for that information. Most people are going to avoid looking for information that proves them wrong. But remember that in science, we always want to be proven wrong. That's the whole point. We want to be held accountable for our ideas. Blind spot bias, another really easy one. It's very easy to ignore information, and especially it is easy to feel as though you are right, or that you are good and that you wouldn't be affected by any one of these issues in the back. Lastly, ethos and authority. This is the idea that it's easy to believe ideas that come from someone who seems trustworthy. So, as an example for this section, what I'd like you to do and what we're going to do now is watch a video. You don't need to watch the whole video, maybe just watch the first 5 minutes or so. This is a video about signs that you are psychic. And while I don't know if there are psychic people in the world, there could be. I just haven't had any evidence or proof of it. And the reason I'm going to have you watch this video is because a lot of the evidence that this person presents makes it seem as though you are psychic or that you might be psychic, but realistically they are falling into a lot of these traps here. So I'm going to link that video in the modules in our web class website, and then I'll make another video just very quickly going through any notes that I noticed that clearly point out that we have problems with the idea. And a good example is that, okay, so would you believe that this person knows about being psychic? Well, they've got this sort of mystical background. They look like they are aware of psychicness. You'll see in the video they kind of talk in a mystical way. There's like mystical sounds. They have a YouTube channel about psychicness, so it seems like it's a trustworthy person on the topic. But realistically, you should avoid assuming that a person is trustworthy and instead always try to check information for yourself when it comes to scientific ideas. So once again, I'm going to link the video and go ahead and just watch maybe the first 5 minutes of the video, and I'll have a reaction video afterwards. Hope you like reaction videos. All right, see you soon.